right, so sorry about the break. Now we are back online. So actually, I was talking about this Thevenin's theorem. Okay, Thevenin's theorem or Thevenin's model. That also helps analyzing and understanding how things are actually working. So tricky electronic schematic drawings, there's plenty of resistors, plenty of voltage sources or signal sources. How to actually start analyzing those so that they start making sense. Then we can use the Thevenin's theorem, which says that any linear circuit containing several voltages and resistances can be replaced by just one single voltage in series with single resistance connected across the load. So that's the Thevenin's model. The single the voltage supply, and in series of that there is the resistor, and that's the output resistance actually right there. And how to make this Thevenin's model to any the okay, this chat window, BSOD black screen of the death. Yeah, okay. So Thevenin's model, simple model for complicated circuits, how to do it in paper. When you try to do it in real life, it generates smoke at some point. So never ever ever use this method in real life, not even on simulated environment, unless you are told to do so. So basically we first determine the open circuit voltage, meaning okay, there's an example coming after this, actually the same example as previous. So determining the open circuit voltage, meaning that the that circuit without a load. We can practically select one of the resistors as a load resistor, or if we are okay. I think it is better to just leave it to the example. So first is short circuit current, open circuit voltage, and then the dangerous part is to determine short circuit current. And then basically the third part is to actually that output resistance is same as the open circuit voltage divided by short circuit current. And now why this short circuit current measurement is dangerous? Buy a car battery, new car battery, and make the Thevenin's model for that one. You really don't want to have a short circuit between positive and negative. It even a cheap battery gives you easily 100 amps. That's a lot of current. Sparks will fly. Okay, and how about measuring the lithium battery short circuit current? Your car battery will explode. It really will explode if it doesn't have any protection inside of the battery. Okay, so but anyways, it works really well in paper. And later on I will show you actually how to do it on safe way also on this without the paper. So Thevenin's model example, there are some series resistors and some parallel resistors here, voltage supply, different drawing, we have +5 and ground here. Okay, so the voltage actually loop here is from 5 volts to another ground, that's the gives you the hint which way the current is flowing. And then think of the what is the U4. We can take that U4 as a load resistor here, and then calculate this open circuit voltage and short circuit current accordingly. So first, and then we have the also that one, and then use that Thevenin's model to calculate the U4 using voltage divider formula. Okay, a little bit complicated, right? But it's also a little bit complicated circuit. So first, determine open circuit voltage. So we take out that resistor here, and open circuit meaning removing the device there. And now what is the voltage? And actually now we have current flowing only via R1 and R2. Since this is open, no current is flowing through R3, so the voltage across that resistor R3 is 0. So basically the open circuit voltage is same as the voltage on this spot. And we have a voltage divider R1, R2 on series. And we can actually take, okay, that VCC on that model is actually same as the U2 on this circuit here, which is same as R2 divided by R1 plus R2. And the numeric formula is right there. So it's numerically it's about 3.33 volts. Next, determine the short circuit current, meaning short circuit we replace that R4 with a wire, such conducting wire, and determine what is the current through that wire. And actually we have there the current division between R2 and R3 in series with resistor R1. So some formulas. So we have the total resistance now between +5 and analog ground. That's the same as R1 plus the parallel resistors R2, R3. That gives you the total current, which is the voltage 5 volts divided by the R total. Everything known, good. And then this short circuit current part here, you can use the current divider formula. So it's the total current times that resistor divided by the sum of the resistors. And well, it looks ugly, but it's actually just, mathematics. It's just replacing those those parameters with the values, and we get short circuit current 1 milliamp. Oh, that's nice. Nice round value. Okay, and finally we have the model VCC is that 3.33 volts, and then RCC is 3.33 kilo ohms. And we have a model there. And finally, the question was about U4, and U4 can be calculated from the voltage division formula. Ha! Great. And it's about 1.82 volts. all of the previous could have been also done by this just taking this only this parallel and series resistor formulas and then finally the Ohm's law. But actually this is also one way. It works really well on very complicated circuits. You make simplifications of the circuits so that you can actually find the solution easier. Okay, there we go. And then, in real life circuit, how to avoid smoke, how to measure the uh, resistance of a battery, for example, output resistance of the battery. So practically, you can measure the, not yet there. Measure the open circuit voltage without the load first. Yep, open circuit, and then replace the load with a known resistance, starting with a big number, and then decrease the test load resistance until you can observe the significant voltage drop of the output. And that voltage drop is actually due to the internal resistance. Remember this one. Let me close some of these. There, a simple system starting simulation at when the resistor is 9.99 ohms, then we have 7.83 volts. But if this one was, say, mega ohms, okay, now we have the full 5 volts there. Okay, changing these values basically to kilo ohms, it's still that full 9, but anyways, when we get into that ohm range, then we notice a significant drop on this one. Actually, that's due to the internal resistance. We still have the same open circuit voltage, so practically that 9.99 gigaohms. This is the open circuit voltage. We have 9 volts inside. So this battery voltage does not change. The internal open circuit voltage is now the same. What changes is the oops, not that one. Oh, yes, it was. Sorry. So what changes actually when we go from giga ohm to 1 ohm is that there's an internal voltage drop on that RVCC resistor, and there is a formula how to then calculate the measurements. So basically, it's the voltage division formula, but different way. We have a voltage drop VCC minus V test here, and we know what is the value of the resistor. We know the current. So current is, yeah, okay, I think that's correct. V test I equals U on. That might be correct. I'm not too sure anymore. There might I may have a fault here, but anyways, my keyboard is messed up, so I cannot check it. Okay. Anyways, so you can actually calculate. Hey, I do have a way to show that. So let's see. So we can calculate, right? So the model, we have 9 volts. This is question mark. And here I have the 9.99 ohms, and I have 7.83 volts, which means I know the current I equals that's U over R is same as 7.83 volts divided by R, which is 9.99 in my case ohms, and then that R here is U per R, still the same, so I'm just using the Ohm's law. U here is actually that voltage is 9 minus 7.83 volts, and then that R was 9. Sorry, you.
I was just about to state.
You divided by I. Of course, you divided by I. Okay, so then we have 7.83 volts, and then we have the R. Yes, times R. 9.99 ohms. Oh, wow. Yeah, that's messy. I should do more, practice on handwriting, I see. But that's very messy. Yes. Okay. So does it resemble even a bit on... Hey, it was the same. Yeah, good. So just using the one formula and then think of the what is the voltage drop over which component. Okay. So yeah, I kind of sort of did this one. Would you like to actually practice a little bit of this one? So if you go and open that on the this example on Tinkercad and click on Tinker. So when you open that link, it opens up. At least it should open you if you have registered on the Tinkercad. It should open you this. And then instead of simulating it, click Tinker this. See what we could try
Just
now.
a quick question.
Yes.
Do you have a class in Tinker that we can join in, or should we just manually create this? Not that it's hard. I'm just, checking if you have already done these exercises and uploaded to a class where we can join in, or everybody just does their own version.
Okay. If you are following this okay, I see. I can actually give you this link directly. Where was the link? Here. I can give you that link on the chat window. I hope the Zoom will work. There we go. On the chat window, there's this link. It's also link on this presentation, slides presentation.
Okay, got it. Thank you very much.
Okay, there you go. Now you can go and click and start tinkering. So next step would be tinker this. Then I have a small exercise for you. And that small exercise is try this with your own values. So the exercise is right here. What is the known resistance value? How about trying the SSS divided by 100? Meaning that in this particular, the SSS would be 999. And try the voltages. They should be different from this one. The higher the resistance, then also higher the voltage, because there's less voltage drop. If there's lower resistance, you would get smaller voltage over there. And then I have the next part. You have probably now that simulation done. Actually, and how to change the values? Well, you just click on the component, then you can actually change the resistance. Make sure that this selection is correct to ohms. Okay, next, submit your measurement values to this form. Hey, there's a form. So, and this form is actually a anonymous. You don't need to dispose any personal information here. So test resistor size in ohms, and then what voltage did you measure, and then calculate the internal resistance yourself based on your own measurements. That's quite simple. I will sketch that example again a little bit nicer on my drawing pad, just to help you start it. So this is s.ss ohms. Yeah, the link. Sorry about that. I need to give the link also to the form. There's the form. We can do some internal plus 9 volts, and here artists. Okay, good. Let's see. Are there any returns? It would be nice if I could press that button now. Ah! Page doesn't open for me. Which page are you referring to? The form or the Tinker? Oh, that one. Okay, let me try it again since... Okay. It something was missing from the first form. Sorry. Again, it's about this problem with my keyboard. I think most of my problems from today is from the keyboard. I think there's something wrong mechanically. Okay. And then some results. Let's see if I can...
I have a quick question.
Yes.
In this Tinker demo, the second part is to measure open circuit voltage without the load VCC. Now you have given us the demo in itself that we can, test upon, but you have the battery, you have the resistor, then you have the multimeter. Where is the open circuit voltage?
Open circuit voltage. Okay, you can actually... Okay, let me stop the simulation and then of course show something. Open... there. So how to measure the open circuit voltage is by, for example, I think you can do it by... Oops. Now I'm in trouble. I think you can do it. The easiest way is actually to put enormous resistance. That's the same as open circuit voltage. So on giga
it's very pixelated. Yeah, okay, so
yeah, pick the
just
highest,
the values up.
Yeah, pick really high voltage, really high resistance. If you have giga ohm resistor, actually it's better than vacuum. On 10 mega ohm resistor, if there are dust particles on the top of it, it already changes the resistance. So practically these giga ohm resistors here, they are as well as open circuits. That's the easiest way. Another way would be disconnect the wires and reconnect them again. Okay, now we have some values already there. I think the problem is that I should be visiting that. Just a moment. I will try to revisit my... Oh, no, it doesn't. Oh, great. Just a moment. This will... doesn't open that. No. It would be nice if this keyboard would work. But it does not work. And it works this functions the probably the worst possible way. The control is constantly on. No. Just keep calculating. I try to get my okay, there are some measurements already. Okay, there we go. So I will show you a couple of things here on that one. So now it's the teaching part. Okay, resistance actually, I think the internal resistance for that 9-volt 9-volt battery model is around 2 ohms. I think it's exactly 2. It's just marked there 2 ohms, and that's it. Been done with it. Then the lower part is actually quite interesting here. Let me expand it a little bit. There we go. That's the power consumed in our test and our battery. Batteries is a quite high power device, so these powers are actually quite high. As you can see, the battery inside of the battery, that's the red, and the blue one is that tested device, that resistor. How much power was consumed? So that's just U times I, and the battery actually the power consumed in battery is there on the lower end is around 20 watts, which is quite a lot. So practically around 4.8 volts there is a point where the battery consumes the same amount of power as actually it should be at 4.5 volts using this test. So remember always that when you are measuring this output resistance, you don't want to stretch too much that output. So for example, these if you are measuring the output impedance of a Arduino or some microcontroller, then use moderate size test resistors. So basically you can easily burn more the power on this device than on your testing resistor, and that's not usually a good way of testing, unless of course you are interested what total power ever, highest power ever. Okay, so that kind of measurements. So you got voltage measurements, known resistors and stuff. Okay, now we would have 1 week break, but before going into break, I will show you what I'm expecting you to do before the next of our sessions. By the way, yeah, that 1 week break means 1.5 hour break before the second part of this course, but it's about this, my show. My show have a 1 week break. So let's go back to the assignments and take a look what should be done there. Assignment 1. Read the instructions and then open this template. Next part would be do the exercise, make a copy of this one, write your name on it, and where to find it. Okay, it was on the workplace assignments. Remember that one. And my bandwidth is actually quite limited now. There is a circuit diagram. And first part is to create this in Tinkercad. This 3-volt battery here actually is the same as the bottom battery. Let's go to the Tinkercad. So this coin cell 3 volts battery in Tinkercad, it's the same as, actually now I should, oh no I couldn't, maybe I can. Since I cannot detach that one, oh shoot. Okay, so that's the battery, what you will be using, CR2032. But not in here, in your own design. Then there are 4 resistors, and you would connect them accordingly. And then there are these test points. So first one is to create the following the circuit, and then you can start measuring. Simple measurements. Measure the current through R3. So R3 is that one, and I'm asking for current. So it means that you would actually put that current meter either between D and this terminal or between B and this terminal. Either or, it's up to you. Then which direction, left to right or right to left. You can see the sign on your, or you can actually also think of it which way the current would flow from higher to lower potential. And then measure the voltage over R2, measure the total current drawn from the battery, determine the total resistance of connected resistors between A and B. Okay, there you need to remember something. Oops. Where I was. So there you need to remember something. So you need to remember to disconnect the power from the circuit. So otherwise you will get error. You can measure error. And then measure the current from point C to D. So there's also current flowing from this point to that point. And in this direction from C to D, not from D to C, but C to D is the positive. If you get the current is flowing the other way, then you should put the sign there accordingly. And what else on the return? Snapshot of your design. So when you have your design, there are few things, a couple of ways you can add a snapshot. There is a share. You can share the snapshot of your design, and actually this would be easy to just take this one and drop it there. Other one, of course, there's that snapping tool, Windows Shift S. Then you can actually take a snapshot of any part of any window. Okay. This is not supposed to be empty. Something has happened to the this exercise, I see. There was supposed to be something else, but okay, you will do whatever there is right now, and I'm not going to add anything more. I just make myself a note for the next time that assignment 1 has only 6 parts. Okay, that's probably enough. So 10 points in total. Okay, so do you have any questions about the exercise? Or anything else? Any other questions?
I have a private question for you after the class.
Private question. Okay, just send me email about it.
All right.
Anything else? Okay, if not, then actually there's the second part of the or second section session starts at 1 o'clock.
The chat is open for
chat. Oh yeah, chat. How do you make the junctions? How do you make the junction? Make the resistors in the range of billions of ohms. Oh, okay, that's probably the how to make junctions. And yes, I am recording this session. Yeah, I have a question about measuring this. What was the current? Current meaning current flowing through. One current, you actually measure the current through this resistor. It's not marked here, but practically, let me go. Current, this is a good example. There are some of these currents marked in this. So what you need to do on that exercise, you will mark your own current, I3 flowing through a component here. Although also this current from C to D. Oh, no, I was asking about that from this demo 9. Ah, which demo 9? Oh, now I'm confused. Sorry, I'm from this demonstration 9. This one? Okay, current. Actually, the current here can be calculated. Okay, there. The current flowing through on this circuit is actually same as the voltage divided by the resistance. So that gives you, that's the Ohm's law one way. So Ohm's law by itself is U equals R times I, and then basically it also means that R is U or I, or I equals U over R. Same formula. So that's how you determine the current, by calculating. In your case, on this exercise, you are measuring them. Measure them correctly, that is. Actually, on this example, let's see if I can actually, I might be able to add here a current meter. How to measure the current flowing through this resistor. I will add multimeter, make it to measure amperage. I will disconnect. Oh no, I cannot disconnect that way. Ha, yes. Okay, that's the positive terminal. Okay. There we go. And then connect that terminal here. Now this device is actually measuring the current flowing through this resistor. Giga ohms, we don't have any current. Ohms, we have tens of hundreds of milliamps. Kilo ohm have microamps. So measuring the current, you will disconnect this connection and then put the current meter in between of that connection. At the middle of that connection. Okay.
So we're going to continue at 1 o'clock, right?
Yes, 1 o'clock, and then Juho Vesanen will be your teacher, and the topic will be about Arduino in this this Tinkercad environment.
Thank you.
Okay, great. So let me take a quick look if there's any other questions. And how to make junctions. Okay, you can actually just whenever you need to connect anything, you can connect those to the terminals. I think there is also a way to have a no, there is no way to actually make a connection in a junction here. No. Nope. Okay, so if there's nothing else, then I will close this session. And yeah, the deadline for the first exercise is 9 o'clock next Wednesday, meaning before the second session starts. If you have any questions, ask to your classmates first, discuss about it. If you don't understand it, then send me email. But first, ask the others first. Otherwise, usually I give more just questions than answers. Now you have been warned. We can't make circuit like that. Okay, no, yeah, yes. So you cannot make this exactly as it is. This is a schematic which was drawn by different software, and it's just a schematic drawing the same way as I have it here. But I could actually make this similar to this model in the in this Tinkercad. Maybe I can actually, let's see, with some luck I can actually make a new one. Circuits. There. Create new one. There were 3 resistors. Resistor 1, 2, and 3. Then I had a voltage source. Well, I just used that battery. I think I can make the connections. And hopefully they look nice. Okay, that's you cannot actually make the connection directly to the wire. Yeah, so you need to do the connections between terminals. By the way, if I cannot easily see your circuit and it looks like a piece of not that good stuff, I will reduce the points. Definitely, they should look neat, something like this. Okay.
Surely you can't be too harsh. This is not an easy topic.
No, I know. It's basically try to make these lines either vertical or horizontal. If it's like this, it's already okay, although that's a little bit like that. Okay, now it's perfect. This would be just fine, but not if you have the. Let me go back, and if it looks like.
Also, whatever you have been showing for the past 4 minutes hasn't been visible to the rest of us because it's been frozen.
Oh, again. Okay, let me try to do something here. Better?
Yes, thank you.
Okay, so this circuit example in Tinkercad, you have these. You can connect only between terminals, like that. Okay, if your picture looks like this, I will definitely give you a hard time. If it looks like that, I will give you less hard time. So basically, it should have the say either horizontal or vertical lines. So this would be.
So you like
okay.
lines? Yeah, I was saying that you wish that we use lines instead of curves or straight lines. Okay, fair enough.
Yeah. So it looks nice. It has to look nice. That's the main purpose. All right. So, okay, good. So anything else? So I think that's all for now. And continues with Arduino at 1 o'clock, the same, the Zoom channel. And this exercise, you can find it from the OMA. And also the other material is there. If you are interested more about the circuit drawings, actually there's a Autodesk Eagle software free to download for the hobby purpose also. 3D design and the Eagle are actually free. So Fusion 360, if you have heard of it, it's open for hobbyists. It's pretty nice. Okay, good. So see you next time, or hear you.
Thank you. Have a nice week.
You too.